Hello, you are all welcome. My name is Junju Isaac. Today I'm taking you through a topic of linear programming. That is Form 4 mathematics. Yeah, one of the challenging topics. So I believe by the end of this lesson, this video, you'll be able to solve most of the problems coming from this topic. When we talk about linear programming, this is the optimization technique aimed at finding the values of variables that maximize or minimize the objective functions. So by optimization, we mean the action of making the best or most effective use of resources. Factories and the businesses actually use this technique in a way of obtaining maximum profits for given costs and production levels. So here we're going to begin with some numerical problems of maximization and minimization, and later on we shall look at word problems where we shall formulate our linear equations. So I advise you, if you don't know linear inequalities, how to graph linear inequalities, that is Form 2 work, please first go and read, or if you cling on, maybe, if you just forget, you may get the idea. Now, let us look at various problems of linear programming. So our first problem is here. We've been taught to maximize z equal to 3x plus 4y. Now, this is our objective function. Our objective is to find the maximum value of this function. Now, you should know that in linear programming, you are always given linear inequalities which serve as constraints. Now, this is a constraint that x plus y is less or equal to 4. Now, the x greater or equal to 0 and y is greater or equal to 0. That is what's called the non-negative constraints. These are also linear inequalities which we have to indicate on our graph. So far we have one constraint here plus these two. Now x and y, these are decision variables. When we talk about decision variables, they will give us various sets of values which we can combine. So once you find a problem of that type, what we always do is to sketch this one on the graph. We need to represent this linear inequality on the graph. So this is a linear equation. We can write it as x plus y equal to 4. Then, this is being a linear equation, we need just 2 points to plot that graph. So we can find x and y. We are going to find the value of x when y is 0, and again the values of y when x is 0. So if we have x plus y equal to 0, what will be x when y is 0? So when y is 0, we put 0 here, x will be 4. And when x is 0, y will be 4. So we have 2 points now. We have 4, 0 and 0, 4. So we are going to plot these points here on our graph. So the graph here, as you can see, the maximum value of x is 4 and the maximum value of y is 4. So I can call this one to be my 0. So this is 1, 2, 3, 4, 5, 6. That is my horizontal axis for x. The maximum value of x is 4, so it will be covered. Now when we come to the vertical, we have y. So we have 0, I can take 1, 2, 3, 4, and 5. Label your axis. This is the y, and this one is the x. Now, the first point is 4, 0. Please, I'm representing this constraint, our linear equation of x plus y less or equal to 4, to the graph here. This is the procedure we follow. We first form a linear equation, then we get to at least 2 points, which will help us to sketch that linear equation and get a straight line. So when you look at that 4, 0, 4, 0 is a point here. That point is there, here. Then 0, 4, that point is here. After locating those 2 points, we are going to draw our straight line. So the straight line we are drawing should pass through our points here. So the points, I have 4, 0, and 0, 4. So this is my line. And that means that this line here should be a solid line. Otherwise, if it was less, we could use a dotted line. That is, if you still recall your linear inequality graphs in Form 2. So I'm using a solid line simply because this was less or equal to 4. Even this point 4 is included. Point 4 is included when we say less or equal to 4. Now, what next? This line represents the equation of x plus y. This straight line is x plus y is equal to 4. That is the line. Now we need to shade the wanted region because this is a linear inequality. Now x plus y is less or equal to 4. Are we shading above the line or below the line? Now what do? We choose any point below the line and another point above the line. So under this line, we may use a point, for example, this one here. It is 1, 1 or 0, 0. Or you can even have 2, 1. We can have 1, 2. Any point or 0, 0. 0, 0 is better. So let us use this point 0, 0. And we see whether it satisfies, this region satisfies our inequality. So if we have x 0, 0, that means 0 plus 0 is less or equal to 4. Is it true? Yes. 0 is less than 4. So this part here is the one we need. So let us check above the line. We can put any point, we can check for any point here. For example, if I take 3, that point is above the line. So in take 3, let us say 3 plus 3, you get 6. 6 less or equal to 4, that one is not true. 6 cannot be less or equal to 4. That means the region we don't need is the region above. So we shade that region above the line. It is the unwanted region. Now after shading, we also have x greater or equal to 0. Now x greater or equal to 0, that is our line. X equal to 0 is the y-axis. Now for x to be greater or equal to 0, that means we need the right hand side of this y-axis. We are moving this side. So the unwanted region would be this one here. All negative values of x are not needed. Same applies here. Y must be greater or equal to 0. So we must start from 0 going up. So any values of y which are negative are unwanted. So this is our resulting graph for the constraints given. This linear equation, the linear equation is given. X plus y less or equal to 4, x greater or equal to 0, and y greater or equal to 0. Now what next? Now to find the maximum value what we normally do is to look for the extreme points. So we have a point here. Let's call that point A. We have a point here. Let's call that point B. We have a point here. Let's call that point C. Now points, the extreme points, we have A. A is what? A is 4, 0. 4, 0. We have point B. Point B is 0, 0. And the point C is 0, 4. Now what we do, we need to find the value of our Z. Remember, Z is 3x plus 4y. 3x plus 4y. Now, we are going to substitute these coordinates into our objective function. Now, for A, x here is 4. So 3x, that is 12, plus 4y, but y is 0, meaning we shall be having 12. If we substitute, that one is 12. Now 0, 0, that means 3x, that is 3 times 0, plus 4y, that is 4 times 0, 0 plus 0, we get 0. When you come to 0, 4, x is 0, y is 4. We substitute in our objective function here, we shall get 3 times 0, which is 0, then plus 4y, giving us 16. Now when you compare, what are we having? We are having 12, 0, and 6. Now the minimum is 0, but the maximum is 16. We are told to maximize. Now the maximum value of Z, our maximum value from the objective is 16, implying that if you want to get the maximum of Z, we take x out, the decision variable here, the variables, x should be 0 and y must be 4 to maximize our objective function.